Welcome, everyone, to another episode of IT Visionaries. And today we have a special guest, the first guest ever in the history of IT Visionaries that focuses on getting people, or does anything, in outer space, I believe. Bruno Carvalho, director at D-Orbit. Bruno, welcome to the show.
Thank you. It's a real pleasure.
Okay, right out the gate, when I go to the website, I'm not even going to pretend I understand exactly what you guys are talking about. Your website, D-Orbit, says D-Orbit is the leader in space logistics and orbital transportation services. I think I know what that means, but I'm not certain. Bruno, can you please explain what it is that D-Orbit does?
Yes, of course. I'll try. I'll try my best. D-Orbit is a space logistics company, as they found out on the website. And by space logistics, we mean putting infrastructure in space. Beyond the launcher, you need to get into a place in orbit. Exactly, you need to get into a place in orbit, and we'll get you there. It's not just about delivering assets into space. It's about delivering capability into space. So we take our customers, we do the last mile delivery, which means after ride shares where you have a bunch of satellites together in the same launcher, we'll do the taxi service into the right spot in the orbit that you require. But we also do, as I said, the delivery capability, and then we start to look ahead and think beyond that in terms of other logistics challenges that space enables.
Okay, so for someone like myself who's not that versed in space travel at all, what do you mean the last mile of delivery? So we know most people know that there's a rocket. Mm-hmm. The rocket has a craft on it. The rocket blows up, ignites, shoots into space, and it detaches from whatever craft it is, whether it's a shuttle, a lunar landing thing, like it's something else that's on the rocket. So that's what we know of.
Yeah. So
after it gets there, no one knows what else happens.
Exactly. So imagine that rocket is the bus service, right? You go you typically go from between two cities, either on a train or on a bus. But then you reach the train station or the bus station, and you still need to get home, right? You need to. So you call a taxi or hop into something smaller that will transport you to the final destination. We are providing that taxi service. So after the launcher, we launched with, for instance, SpaceX. We were on our first Transporter 1. They beat the record of number of satellites on a single launcher, 143, if my memory serves me right. And of those 143, they left into the, say, train station. So what happens next is that we are the taxi service that is going to deliver the ones that are inside our vehicle into their final orbital positions.
Okay, so this is mind-boggling stuff right now. I think your description of using public transportation is 100% very clear. But then my brain starts thinking about, like, how much does that cost and how much do you charge for this? Because you have, whether it's manned or robot operated craft in space to receive other craft that have now
we are already in the vehicle. So
you're already in the vehicle.
Exactly. So it's like those trains where you put the car inside,
or like a ferry. A ferry's a boat, but it has cars inside.
Exactly. So we are the car inside, and the passengers are inside us already. So it actually doesn't for our passengers, for our customers, it doesn't cost much more than flying solo on the rocket. It's a different proposition. So again, we're looking into taking our passengers into or our customers, the assets of our customers to the places where they need to be. If you think about deploying a fleet or a constellation of satellites, then you think about putting those spacing those into the right orbital planes and allowing the fleet and the constellation to enter into service much quicker.
So this is where the business side of this starts. My mind starts turning because I can't, I would say for many people, it's hard to imagine things that they don't quite understand. So that's where I'm at today. This is a fascinating thing, what you just now described to me. Because when we go try to look up, for example, D-Orbit's funding rounds or something like that, I mean, we can find that it was 17.7 million raised. But that's nothing compared. Like software companies raise 30, 40 million. That's just to make code. You guys are making... What are you guys making? It's not just code. It's code. It's machines. It's all kinds of stuff. I'm assuming. How does it all meld together?
In a sense, we are building a satellite, like a vehicle, right? So we're building a spacecraft, and by spacecraft we mean something that will orbit the Earth. It's about the size, I don't know, a bit bigger than a washing machine, and you just put passengers, we are providing a service to smaller satellites. So I'm not sure if you're familiar with the CubeSat thing. So it's basically a CubeSat started with university projects, and someone just started to standardize shapes of spacecraft, and they came up with a small sat form, what they call CubeSat, which is a 10 centimeter by 10 centimeter by 10 centimeter satellite. And then that's called the 1 unit. And typically what we do is that we provide, you put some of those together, you have 3 U's, 6 U's, 12 U's, and so on and so forth. But they're all kind of the same form factor. So very small things. You know, the box looks like, could have a bottle inside, the kind of it's 30 centimeters by 10 by 10. And we're putting those into, so these things normally are very capable in terms of what they are aimed for, in terms of observing the Earth, or communications or Internet of Things, and so on and so forth. But they don't have propulsion. They don't have means to get to their location. So that's what we're providing. We're providing the service to put them into the right place. It's quicker than they would normally go.
So how did you get involved with this mission? Because we did a little homework on you via LinkedIn and such, and we see that you've been working in, I don't know, is it fair to say some form of space for quite some time, like satellite databases, working at different companies?
Me personally, I've been working in space for the last 16 years, probably. Different types of missions, from big science missions that cost in the billions to smaller things. I started working with the Orbit 2018, probably, and I was still in the UK at the time. And the challenge was they were going through the last funding round, so they're going through one of the investors, Seraphin, who's based in the UK. They're setting up shop there and starting to try to define a team, work the business case, and so forth. At the same time, I was moving my family back to Portugal, where I'm currently based, where the Orbit already has also an office. Actually, they came to Portugal on the back of a contest, kind of a challenge that was put together by MIT and in partnership with the Portuguese government, where they won with another product that the Orbit has. It's the Orbiting Kit, and I was challenged to take responsibility for the operation here. So basically, start looking at what role would the Portuguese office provide, in tandem with what was being done or started in the UK, and then obviously all put together and all centralized in Italy, where the company's headquarters are located. It's been a journey. I mean, for me personally, I'm passionate about space, so it's really cool to be doing things that nobody else is doing. It's thinking a bit out. I don't like the expression outside of the box, but it's thinking a bit outside of this world. Maybe it's a bit different.
Yeah, I mean, so I don't know why I've never really thought about it, but like before doing the research for this interview, I never really even thought or considered that the objects in space couldn't get to where they actually needed to go. Like I never realized that it was sent. I just assumed that everything got sent up there with its own. Like I thought that was the duty of NASA. Like if you're sending up a satellite, you build a propulsion system to get it to where you're going. But you're saying that's not the case, that they leverage technologies like yours to then take the satellite doesn't have its own propulsion. They don't build it. So and you said it's deorbit, right? That's how I pronounce the name of the.
You're correct.
So the deorbit makes the machines as well as the software on board that then can program it and say, hey, this satellite needs to be over Antarctica, wherever it needs to be, right? And it moves it there because I don't know why. Why do most people understand that these machines are sent up without their own propulsion systems? I have no idea. When you talk to people,
I don't know. I don't know. Once you're in a business for a bit of time, you start losing a bit of what other people do not know about space. You start engaging in a different way. And I think you're right. I think maybe it's not clear. And to be honest, I think I think things are also going beyond what NASA does. And we are a private company, and we work with private customers. So I would argue that our institutional market, particularly even in Europe, it's relatively small. I mean, we are based in Europe, and most of our customers have been US based or elsewhere. And and we're the first to do it, in the sense that we're the first to actually, we're currently operating 3 satellite deployers, as we call it, or space tugs. And we are planning to launch a few more next year. Already fully booked until April, I think, if my memory serves me right.
Wow.
And the thing is that we are thinking beyond that. It's about, as I said, delivering capability. So after the mission is after the passengers leave the taxi is still a car, and that car can still provide services. So we are flying computers in space. We're starting to have edge computing capability, so that you can leverage the capability of an asset that's already there to do other cool things. So you start thinking about deploying applications and software, as you mentioned, instead of hardware into space. And we can do that already. The bottleneck is typically, from a space application perspective, the bottleneck is typically the ground communications. The antenna being available for when the spacecraft comes over, and so on and so forth. It's interesting.
Yeah, it gives a whole new perspective to like getting a software update, right? Because when we get software updates, we are always near, let's say, a Wi-Fi signal, or we're always near a cell signal. And if you're updating your satellite and you need to get software there, then I need to call up the orbit to say, hey, I need to send this code over, because there is no over the airwave. I guess it's just satellite to satellite communications while my satellite orbits near you to then deliver.
There are several ways to do it. Yeah, there are several ways to do it. Typically, most satellites will have links to the ground and the capability to patch their software. Their control software, attitude control and so on and so forth. What we're trying to do now is to provide mechanisms for you not to upload applications, to upload algorithms to provide. We can provide you data from either other satellites or from other instruments that are currently on board for you to do your cool things. I mean, it's like having a phone where you have an app that you can develop because you can use a camera or you can use the sensors on your phone. If you provide a bunch of sensors in space and some instruments and some computer facilities, what would you do with it? That's a challenge. I mean, happy to, if you have ideas, share them.
I'm just trying to help. Hopefully our audience at IT Visionaries doesn't listen to this episode and think to themselves like, man, this host is an idiot. He does not understand anything, because I'm learning from you as we talk. You hit at it just a second ago, but I wanted to further discuss. You mentioned before that most people when they think of space, they think of like maybe government, like I said, NASA, right? But you're saying, hey, that's not actually the case anymore. There's a lot of private organizations that have whatever they need to get to space. I saw and we read a little homework about AWS Ground Station, which is an Amazon AWS. For you guys listening out there, yes, AWS, Amazon Web Services. There's a partnership there with the orbit. We saw some stuff with SpaceX. That seems to make sense. SpaceX obviously is trying to figure out space travel. Talk to me a little bit about what are some of the things that these private companies are trying to accomplish in space.
So let's break that down in smaller pieces. The partnership with AWS is there's 2 parts of this. One is the actual we're using their cloud infrastructure for our own software. So we have our own control software. So we actually need to operate those satellites. And whilst in the past, most of the companies and still most of the institutions that you mentioned still, use kind of monolithic solutions like applications that will have their dedicated servers and so on and so forth, because they need to be in a closed room with keys and access cards and everything. We're now deploying our software to control our satellites in AWS, so in a cloud infrastructure. So that allows us to minimize our own investment in terms of the infrastructure that we require, but we also, the pay as a service and so on, and so pay as you go. That is really useful for a startup, because we don't have to invest into a bunch of servers and maintain those that are, in 3 years' time obsolete and so on. So that minimizes the capex for us. The second part of that is that they deploy what they call the ground stations, Amazon ground stations. This is basically Amazon putting an antenna on every data center that they have and putting partnerships with other antenna providers. That means that we can not only control our satellites through their network, but also have access to the data immediately on demand on the cloud. So they minimize the latency that for the data that's coming from not just our customers, but also ourselves to be readily available in a cloud infrastructure that will allow you to deploy algorithms, correlate with other data sets, and so on and so forth. So that is giving to space which is always lagging behind in terms of technology. It seems like counterintuitive, but it's true. I mean, we only fly technologies that are proven, so the computer needs to fail many times on the ground, and we've probably flying 2 or 3 iterations backwards so that it works. But we are approaching the same logic, of Silicon Valley, of the startup, which is fail and launch. And because the costs are coming down, and people like SpaceX bringing the cost to orbit down significantly, that's much easier to do with still have to have the safeguard mechanisms, because we don't want to just send debris into space, and we want things to work. But we're bringing the same kind of architectures of software to map into space, because the flip side of that, which is what we're deploying in space, is also the computing capabilities that are linked with that cloud infrastructure. So we are deploying cloud infrastructure in space now. As I said, after the taxi service, there's still a very capable service module and a very capable spacecraft with some computing capabilities in space. So we're linking that two together, and AWS is a bit of the glue there.
So in your mind, what do you think this is going to unlock? Because this, whenever we think of space, most people immediately jump to the future, as in there's going to be future implications, the betterment of humanity, society, however you want to phrase it. What are some of the things you think are going to be unlocked by this new capability of bringing the cloud to space?
I mean, to be honest, I hope that the people are not limited by my own imagination, because I think we don't know what the future holds. What we're trying to provide is the infrastructure and the capabilities for people to use. I mean, a bit like the spare capacity and computing power that Amazon had when they made it available for web services. They didn't know what people were going to deploy. So we don't know either, but we have some ideas. I mean, because if you think about going beyond Earth orbit, if you think about going, to the moon and to asteroids and to Mars, then you start looking into deploying capabilities in those local environments. You want to minimize lagging communication. You want to minimize or to maximize the bandwidth that you have available within that local infrastructure. So it's creating that capability into that's required. In terms of applications, I'll give you a quick example that we are actually now testing. So imagine that you have a satellite that is typically downloading the data over a site that's about 2 days old. So the revisiting time is 2 days because the orbit, that's the orbit that's defined. Typically weather satellites are like that. So if you download data from that satellite, you can potentially in space download data from another satellite in space. You can potentially process that information in space and generate alerts for fire detection or something, which are real time, immediate, because before the satellite passes over the next ground station for you to download and say, oh, there's a fire, but the fire was 2 days ago, so it's a bit late to deploy the fire services. So alert generation is a good example of things to do in orbit, but you do other things. You do debris detection, so for collision avoidance, and by collision avoidance, I really mean collision avoidance in space. Things are getting a bit a bit crowded there. So yeah.
How many? Yeah, you mentioned just a moment ago, like things are getting a bit crowded. That seems hard to imagine because, when for example, I drive on the road, I see how many objects are currently on the road, and we're trying to figure out autonomous vehicles here. How many objects are in space right now?
Thousands. We have launched since Sputnik about 8,000 satellites. We plan, the estimation until the end of the decade is about 35,000 just this decade. You mentioned SpaceX, Starlink is already on 1,600 satellites or something like that. And you can see them. If you look up, you can see them. If you're not in a very, if you go away from light pollution, you can see them.
That is wild. I'd see I always knew, I haven't been keeping up on it that closely. I always knew companies were using satellite weather reading systems, data collection systems. The government was doing it, military was doing it, private industry was doing it. But 35,000 objects right now?
Not yet. The more objects that are not operational that are probably the problematic ones. The ones that are operational that we know where they are, it's fine. But we already had collisions in space. 2009, if my memory serves me right, you had the Iridium versus Cosmos, which is basically two big satellites colliding, which just generates debris. And if you think that those objects are traveling at 25,000 kilometers per hour. It's one speck of ink, and you Google this and you'll find it. One speck of ink will create some holes into things like the ISS. There's this they have warnings every week.
That makes total sense, because if you shoot water at high enough pressure, it can be used to cut steel. So everything in space is circulating around orbiting around the Earth at, what did you say?
27,000 kilometers per hour.
27,000 kilometers an hour. So a droplet of ink is a problem out there.
Yeah.
I didn't even really think about it that way. Jeez.
It's a lot of inertia, and some orbits are getting crowded. So the orbit, as I said, started with a contest, and with the original business case was actually the orbiting kit, which was still produced, and we still pretty much in our catalog, which is basically a device that you put in your satellite before going up, which is basically the red button to say if you lost control of the satellite, even if it's unreachable, you press the red button and everything will deorbit itself and re-enter the atmosphere and vanish. Because we need to clean up, and sustainable use of space is one of the things that trigger the orbit going into logistics, which is, you have to manage the space around us, and by around us I mean Earth, and we're now looking into cislunar space and beyond, and manage that to be sustainable for future generations. It's a problem. It's not something that people think too much about it, but it's a problem.
Yeah. So what do you see, I guess, a place where you guys going to start engineering? Because you mentioned space logistics, moving objects. Do you see a place where you're going to go get these things and pull them back onto Earth, or put them somewhere else?
Yeah, that's already being thought through. Yeah, that's exactly the plan.
What is the thought? Do you bring it back to Earth or send it even further away?
It depends on their position, because there's a lot of energy that's required to do either thing. So if they're closer to the Earth, you bring them down. If they're farther away, you take them elsewhere. And the same taxi that will deliver stuff in space can be used to then pick up other garbage or other things. And there are several experiments. We're not the only company doing it, but several experiments being thought through, from harpoons to fishing nets to robotic arms to. I'm serious. It's an interesting problem, and it's a challenge because it's not. It's an harsh environment. controlling it's three-dimensional, not necessarily with cooperative targets, approaching them, making sure that you don't collide. It's a challenge.
Yeah, and these objects are also traveling at 20 plus thousand kilometers an hour, right? So you're going to try to harpoon something moving at 20, I believe you said 26,000 kilometers an hour.
Yeah, 27,000 kilometers per hour. Yeah.
You're going to harpoon it, catch it, and pull it back just so you can bring it back.
Yeah, hopefully these things, when you approach them, you synchronize that movement, right? So relative velocity becomes a bit easier to manage, but you still need to get to that place, and the control part of that is the challenge.
Yeah, you'd have to time I get what you're saying. You have to time your rotation or whatever your navigation. So you're in the same. You're traveling at the same rate of speed. So at that point, it's gonna feel like you're just shooting across the way, but you're both going at 26 or 27,000.
But you still need to get there and close enough, and that's the real challenge.
Yeah, like a harpoon line is like what? I don't even know how many feet you would do it, but like let's say 1,000 feet. Like that,
you have to be close. You have to be relatively close. In the grand scheme of things, it's close.
Yeah. So I got to ask, because this has been a topic of conversation for many of our guests that have been on TV Visionaries, which is what skills and knowledge is Deorbit looking for? Because every company's trying to get that next wave of talent. This is so foreign to me. I don't quite understand. But like, what type of people are you guys looking for to work there?
So a lot of software actually, and we don't care really about the background. We have, as I said, we're deploying web software like AWS-based cloud software. And actually, we are actively recruiting. We have about 30 positions open on several sites, and we grew from about 60 to 160 in the last 9 months, even during COVID, which is quite interesting. But yeah, software, it's as important as every other industry. And then I think that the key challenge is engineering on like in space engineering. So some different electronics. I mean, we have to care about the electronics, which is you have to care about the environment where you operate in those electronics, so harsh environments. And then there's the flight dynamics, which is physics in its essence. So.
Yeah, hard. I'm sure that's a hard talent to come by now lately. Everyone's talking about how there's not enough engineers, not enough science, not enough STEM students or workers.
We're trying something actually. I mean, we're all very active into try to promote these things in the outreach programs. I mean, I hope that being here talking to you actually enables that as well. But we're doing something that we hope that it's going to ease the access and making these things available for people. Don't be scared or frightened about the challenge, which is what we call the Deorbit Academy. And we're trying to reach out to undergraduates and even below, but also because there are things that for tasks and things that you don't have to be a master's or a PhD or anything, but you need to have the right skill set and the right attitude and the right mindset, I suppose. So we're training. We do a lot of in-house training. So you either with graduates or recently graduate who work a lot with universities, so pitching ideas so that they can do their thesis or challenging their students, and we try our best to widen the pool of potential resources that and pool of people that we can that we can reach. So it's working remotely these days. But we hope that makes it a bit easier.
Now, one of the unique things also is you are based in Lisbon, Portugal. Is that right?
Yeah, correct.
What made Deorbit select that location as a place to send you to build an office? Well, is there a unique community there that is or a lot of access to universities that are studying these subjects?
Yeah, Portugal is well, first it's a great weather and a great location and it's peaceful and everything else. But more importantly, it's access to brain power. So we do have very close relationships with 3 or 4 universities here. And as I said, really to challenge students and to challenge the teachers themselves. Uh, and it's working really well. I mean, it's I think the Orbit and the founders came here almost by accident, as I said, on the back of a business contest in terms of it wasn't it was a prize, right? That they won, so they got some funding to kickstart things here. But they stayed, and they've been in Portugal for, I don't know, 7 years now, and they stayed precisely because there's their access to the market. The other thing in Europe, and this is also one of the reasons why the Orbit is expanding into other locations in UK and looking at the US as well for obvious reasons, but other locations is not just to enlarge the market, but to enlarge the pool of potential people that we can recruit. But it's also to play with something that in space always exists, even if it's a commercial venture, which is the geopolitics of the whole thing. So with the UK, with Brexit and the European Union, Portugal tends to be neutral in some of those aspects. So it's.
Yeah, and as far as I know from Portugal, I will piggyback off that for those of you that are out there and not familiar with this. Portugal is one of the stops on the World Surf League Tour, World Tour, Super Tubos. So if you love surfing and you like going to space
and the big
you're
waves.
Qualified.
And the big waves in Nazaré.
Nazaré. Yeah, there you go. Exactly. 100-foot waves. So if you want to see some epic natural conditions, and you're also, I mean, I don't even know what subjects you need, but like astrophysicist or something. You want to work with Bruno, give him a shout. Bruno, it was awesome having you on the show today, sharing some of the ideas. But before you go, it is time for the lightning round. The lightning round is brought to you by Salesforce Platform, the #1 cloud platform for digital transformation of every experience. Bruno, this is where we ask you questions outside of the world of work so that our audience can get to know you a little better.
Sure.
All right. Some of our questions will still be about space, though, possibly, because it's a fascinating subject. All right. What movie or book did you read or see that got you into science fiction in outer space?
Oh, plenty. I mean, I can name you all the authors from Heinlein to
What was the first one?
Clark.
What was the first one that got you fired up?
Yeah, my best, I think, is The Moon is the Harsh Mistress by Heinlein. And if we got about movies, probably Blade Runner.
Blade Runner. What about Blade Runner particularly pulled you in?
No, I think the whole. It's not just the theme. Obviously, the theme is very profound, but it's the almost dystopian kind of still hopeful world. It's really out there. When I saw it, I was 10 or 11, so it's a while ago, and it's really cool.
When you were younger, did you think you were going to be an astronaut, or did you think you were going to be something else?
No, I mean, I applied to the Air Force for jet piloting, but I couldn't because of glasses and everything. I will always wear these. But I mean, astronauts, people want. As I said, I do those outreach things, and the people say, I ask the kids, "What do you want to be?" And they say, "Astronaut." Yeah, but astronaut to do what? And you still have to have another profession before you become an astronaut. You need to be, a doctor, a scientist, a pilot, whatever. So what's the base? What's motivating you before going into space? It's really important.
No, I love that. On your LinkedIn bio, you have something interesting. You say, because space is hard and needed and fun. Besides space, what else is fun to you?
Well, I paraglide, so I'm still
paraglide.
Yeah.
Like the self-propelled, the ones like the little machines, like the fan.
No
thing,
engine, no. It's just soaring. Okay. Yeah, just soaring like a bird and going on thermals But I've been paragliding for about 20 years now, and I do tandem flights. You're more than welcome to come over and also try that. I do fly with my kids, and I used to play the saxophone. I'm not sure if I can pick it up and do it again. But yeah.
Now, Portugal is known also for its vibrant food culture. Most people who have been there have only great things to say about that. Let me ask you a question. What is your favorite Portuguese dish?
Oh, bacalhau alagareiro. That's a tough one. So imagine the salted codfish just with garlic and olive oil and some nice potatoes. But yeah, I mean, it can go on forever. It's very, very, very hard to choose one. It's very hard to choose one.
How did you pronounce that again?
So bacalhau, which is the salted cod, the dry salted cod. Alagareiro, which is basically means the lagar is the place where you produce the olive oil. So the when you crush the olives, and yeah, so it's I'm hungry now.
Yeah, it sounds intense. Yeah, I've seen my brother went to Portugal. He was there for an extended period of time. He sent back pictures. He's a foodie. He would send pictures to me of like every dinner or lunch that he had. I mean, everything always looked epic and amazing. So, and I've only met a handful of people that have been there, but every person that I've ever met that's either A, from there, or B, visited there has said the food culture is amazing, that you will eat something unique and exotic pretty much every meal.
But although
unlike other places.
Yeah, we do go for some crazy food, I suppose, in terms of particularly even in European standards, I suppose. But it's a kind of a Mediterranean type thing, right? So a lot of olive oil, a lot of garlic, a lot of seasoning, a lot of salt probably as well. But okay. It's I mean, we do try a few things to keep it simple. So if fish, for instance, is the simplest way possible. It's just on the grill with a bit of salt, and that's it.
Well, listen, if IT Visionaries ever comes out to Portugal, Bruno,
give me a shout.
I'm going to reach. Yeah, I want a tour. We'll be out there. Me and Aaron will be out there surfing, enjoying Lisbon. Hopefully, catch a meal. We would love to come to your office, but I don't know if we would understand what we saw.
No, it's fine. You'll see computers anyway. You won't see anything different than the software house. But you mentioned we have one of the world surf reserves. So it's about 20 miles away from where I live. So I'll definitely take you there.
Perfection, Bruno. Thanks for joining us today on IT Visionaries.
It was my pleasure. Thank you very much.